The main objective for this competition is to score the maximum amount of possible points while still adhering to all of the competition guidelines. The theme for this competition is based on the movie The Matrix and requires the teams to complete 4 main subtasks. The first point scoring task will be to retrieve the programming modules. These modules are represented by tennis balls and are lined up along the edge of each team's home zone and worth 7 points each. The second task is to remove the Sentinel, which will be represented by a rubber dog bone and is worth negative 13 points. The third task is to take the red pill and not the blue pill. This is accomplished by taking the red pills, represented by ping pong balls, and placing them in the red zone and not the blue zone. Each pill is worth 5 points. The overall pill scored is doubled if the pills are dropped in both red zones, as well as if the machine egresses from the EMP blast zone. The fourth and final task is to retrieve Morpheus and bring him back into the team's home zone. Morpheus will be represented by a small plastic Morpheus doll, which will be sitting on top of the Matrix and surrounded by a shield at the beginning of the competition. This shield will drop at a random time between 5 and 17 seconds after the track has started.
This is our House of Quality, which relates customer and engineering requirements. The most important requirements are highlighted. Durability factors into the machine's ability to handle dozens of test runs as well as the qualifying and final competition rounds, so that rated highly for us. Its performance will ultimately be evaluated by how high it scores, so scoring potential also rated highly for us. The machine must meet the given size constraints of 1 foot by 2 feet by 1.5 feet in order to avoid a disqualification. This will dictate design choices such as mechanism design and material selection, so we rated this highly as well. Additionally, arena testing will be the best way to determine if a given subsystem is performing properly, so if we have highlighted it as an important engineering requirement. The function tree shows the major functions of our machine and any subfunctions that may exist under them. The most difficult functions were determined to be pill placement and Morpheus retrieval because each had multiple subfunctions due to sensing requirements. This focused design efforts around these tasks and integrated other functions around them. Our spec sheet lists necessary specifications for our machine. The given size constraint was the most important specification as it forced the team to think of ways to fit each subfunction in a functioning manner. The next most important specification was to avoid damaging the track in any manner in order to avoid disqualifications. Next, there are desired quality specifications about accuracy in the test runs for each subfunction. This gave the team goals to tweak the design towards in the testing phase of the project. The morph chart depicts solutions to the subfunctions shown in the function tree. The solutions in this chart were incorporated into preliminary designs and evaluated on their space efficiency, speed, accuracy, and ability to integrate with other subsystems. These are some of the alternate designs. Some of the interesting ideas here include a wedge to push the red pills of other teams out of the pill zone, a spring-loaded flap to remove the Sentinel, a scissor arm to grab Morpheus, and a mechanically driven gear and conveyor system to place pills in the proper zone. However, some of these ideas were disadvantageous due to their complexity, reducing the time spent on testing in favor of construction instead. Ultimately, the use of an evaluation matrix made the final decision on which design to proceed with. Our evaluation matrix compared all of our alternate designs. The Neo Jacket was the winner with 297 points. Since the team assumed that removing the Sentinel and obtaining the programming modules would be the easiest points to obtain, each design's performance in these tasks was weighed heavily. The Neo Jacket also came ahead due to its ability to consistently egress from the pill zone and place pills in 2 different red zones, greatly improving its scoring potential versus other designs.
The Neo Jacket is designed with a base platform which is centered with the narrow edge facing the matrix. Mounted to this base are a set of drawer slides which are connected to a moving base that extends out over the track towards Morpheus. The moving base also has a set of drawer slides attached to it, which delivers the pill subsystem to the center of the matrix. A pneumatic piston is connected to the moving base, and as the banana plugs are activated, the piston extends, pushing off of a wall connected to the stationary base and propelling the moving base forward. A solenoid attached to the top of the moving base then retracts and releases the pill subsystem, allowing it to reach the matrix, sense the red zone with a sensor, and then drop the pills into the red zone. Attached to the front two corners of the stationary base are arms used to retrieve the programming modules. They are first pushed out from the Sentinel subsystem and fall around the programming modules. Later, when the machine is egressing from the EMP blast zone, programming module arms are pulled back as part of this aggression, bringing the programming modules into the home zone. Attached by a hinge to the front of the moving base is a small arm which first pushes out the programming module lever arms. Once the moving base has extended towards the matrix, the flap will be pushed over using a pneumatic piston and will land around the Sentinel. When the machine egresses, the Sentinel will be dragged back into the home zone, effectively defeating it. The PIL subsystem is connected to a raised platform which is connected to a set of drawer slides attached to the moving base. The PIL platform will extend to the EMP blast zone, and a roller switch attached to the bottom of the platform will sense the beacons to differentiate between the red and the blue PIL zones. On top of this platform is a motor mounted into the base of the PIL platform, which is attached to the PIL door. As the motor rotates, the PIL door moves enough to allow one set of pills to drop into the first red zone, and the rest of the pills into the second red zone. The Morpheus subsystem is a simple design and does not attempt to directly save Morpheus. Instead, an arm flips onto the lower rotating area by way of a mousetrap that is initially held down by an equal screw. Our group initially noticed during testing that almost no other groups were sensing the shield drop, and instead decided to go after Morpheus after a designated time. Because of this, each team would be going for Morpheus at the same time, and usually Morpheus would be knocked down onto the rotating matrix. Our arm is designed to guide Morpheus off the lower platform of the matrix and into our team's home zone.
At the various checkpoints during the semester, the machine's subsystems scored well in studio competitions. In the programming module competition, the machine received 98 out of 168 points, which averages to 4.67 modules per round. Our score was the median for Section C. In the Pills and Morpheus competition, the machine received 90 out of 240 points for the Pills and 0 out of 50 points for Morpheus, and was the only machine in Section C to score in either portion of the competition. The most difficult hurdle to overcome was the integration of the PIL programming module and Sentinel subsystems. During the qualifying round, this integration was not complete, causing poor performance and landing the Neo Jackets in the 56th seed for the final competition. On competition day, the Neo Jacket performed moderately well. In the first round, 34 points were awarded, placing the team in second place for the round. These points were gained by successfully placing 4 red pills in 2 red zones along with collecting 2 programming modules. The egress system failed because the string was not hooked up correctly, causing the team to lose out on 53 points for not leaving the EMP zone and not removing the Sentinel. In the second round, 74 points were obtained, placing the team in first for that run. The egress string worked in this round, but the string pulling back the right arm snapped and was unable to be fixed. In the third round, the team was awarded 7 points. Misalignment caused the PIL system to only place 2 balls in one zone. The programming module arms deployed faster than the other teams, but could not be pulled back. The increased friction caused by the new paint on the tracks caused an unsuccessful removal of the set. In conclusion, most of the failures of the Neo Jacket on competition day were due to human error by not hooking the egress string correctly and misalignment. It is possible that changing the egress string to a strong material, such as a metal chain, would have been better suited for pulling the machine back to Zion. The Morpheus system proved to be ineffective since no other team attempted to rescue him in any of the 3 rounds the Neo Jacket participated in.